Now we're going to introduce a shortcut for integration of the function sine to the power 5x cosine square x. So let's go ahead and list the function. So we want the integration of sine to the power 5x cosine square x dx. Obviously, sine to the power 5 of x complicates the issue. So we have to rewrite sine to the power 5x into three parts as follows. Sine square x multiplied by sine square x multiplied by sine x, and we leave cosine x dx as it is. Our next step is to replace sine to the power 2. We have to replace sine square x by a function that involves cosine x. And to do so, since sine square x plus cosine square x equals to 1, we can conclude that we can replace sine square x by 1 minus cosine square x. If we do so for equation number 2, we're going to get equation number 3. The only difference is instead of sine square x, we have 1 minus cosine square x. For both of these two are replaced by 1 minus cosine square x. The rest is the same, except that we change the position of sine x with cosine x over here. So we have cosine first before sine x. Over here, sine before cosine x. These two are equivalent to whatever is in between these parentheses. 1 minus cosine square x multiplied by 1 minus cosine square x is similar to saying sine square x multiplied by sine square x. So this equation number 3 is identical to equation number 2. Now the next step is we have to carry out the multiplication of 1 minus cosine square x by 1 minus cosine square x, and what we're going to get is the following: 1 minus 2 cosine square x plus cosine to the power 4x. We put them between curly brackets. Now we have to get cosine square x inside the curly bracket, and if we do so, then we're going to have to multiply it by each and every one of these three terms, and this is what we're going to get. Instead of 1, we're going to get cosine square x, and instead of cosine to the power 2, we're going to get cosine to the power 4, and then of course the coefficient is the same. And instead of cosine to the power 4, we can get cosine to the power 6 because we're multiplying by cosine square. And then outside we have sine x dx. Now the last part, before we can perform the integration, we have to figure out how we can replace sine x. We want to replace it by something that has cosine x. And to do so, let's go ahead and look at this. Since the derivative d by dx of cosine x is equal to negative sine x, then we can conclude from this by multiplying the left hand side and right hand side by negative dx. We're going to get negative d of cosine x equal to sine x dx. Now that since negative d of cosine x equal to sine x dx, then we can replace sine x dx by negative d cosine x. So we're just going to remove this and replace it with negative d cosine x. We take the negative outside over here, and that's what we're going to get. So we're going to get the answer as what? As integration of negative, which is this integration in equation 5. Integration, we put the negative. One more time. We have to replace sine x by d cosine x and negative sign. So we'll put the negative sign outside and we'll replace sine x dx by d cosine x, which is right here. So now we have an equation that has all the variables cosines. Now we will treat cosine x as a variable, not as a function. If cosine x is as a variable, it's just like we're saying dx. So we're saying d, the variable. And all we need to do is just to carry integration the way that we are familiar with. Integration is carried by raising the exponent by 1 and dividing by the new exponent. If we apply that, so we will treat cosine square x as a normal variable. So its integration will be 1 over 3 cosine to the power 3. We keep the negative outside. So this, raise the power by 1 and divide by the new power. You get 1 over 3. There, raise the power by 1, it will be 5, divide by new power. You'll get 2 over 5. Raise the power by 1, divide by the new power. You'll get 1 over 7 cosine to the power 7. And then, because this is indefinite integral, we put plus constant. So this is the answer of the integration of sine to the power 5 x cosine square x. However, to verify this answer, we have to go ahead and use the fundamental theorem of calculus. Let's see how we can do this. Now it's time to prove the shortcut for integration of the function sine to the power 5 x cosine square x. Let's go ahead and recall that we have to do that proof by using the fundamental theorem of calculus. So let's recall the function and its integration. It's as follows. The function is sine to the power 5 x cosine square x dx. Its integration is negative of 1 over 3 cosine to the power 3x minus 2 over 5 cosine to the power 5x plus 1 over 7 cosine to the power 7x plus constant, because this is indefinite integral. Now, the fundamental theorem of calculus states that if we do the derivative of an integral, then the derivative will annul the integral. And for that, we're going to go ahead and do the derivative of the left-hand side and the derivative of the right-hand side. So, derivative of the left-hand side cancels the integral, and we will be left with just sine to the power 5 x cosine square x. And the dx goes with the derivative, because if you cancel the derivative with the integral, then this is part of the derivative will also be cancelled. So the derivative of the right hand side must be equal to sine to the power 5x multiplied by cosine square x for the cut short to work. So let's go ahead and do the derivative over here the normal way. When we do derivative, we take the exponent multiplied by the variable and reduce the exponent by 1. So if you take the 3 multiplied by 1 over 3, it's going to give us 1. And reduce 3 by 1, so we'll get what? We'll get cosine square x. So let's go ahead and show. So we're going to go ahead and have cosine square x, which is right here, cosine square x. But this is not a function, this is a function of a function. That means we have to do the derivative of the outside and then the derivative of the inside. Derivative of the outside will be equal to cosine square x, because we have to multiply by 3 and then subtract 1. So multiply by 3, we get 1. Subtract 1, we get cosine square x. And the sign we will see now it's going to be neutralized because we have to do the derivative of the inside. This is just the derivative of the outside. Derivative of the inside, that means derivative of the cosine. Derivative of the cosine will give us sine. So derivative of sine x will give us negative sine x. And negative sine x is going to neutralize this negative. So it will be positive sine x. So the derivative of negative 1 over 3 cosine x is going to give us cosine square x sine x by the chain rule. Likewise, by the chain rule, 2 over 5 cosine to the power 5 x, its derivative will be equal to 2 cosine to the power 4 of x and then sine x. In the same manner, first we get the derivative of the outside, which will give us 5 cosine to the power 4. But 5 goes with the 5 in the denominator, and we'll have just 2 and then cosine to the power 4. We have a positive sign here, but then we have to do the derivative of the inside, which is derivative of the cosine x. That's going to give us minus sine x. That's why the minus will change this plus into a minus. And then this is derivative of the inside, sine x. Likewise, for the cosine to the power 7 x, we do the derivative of the outside. It will give us 7 neutralizes 1 over 7. So we will have just cosine to the power 7 minus 1. And since we have to do the derivative of the inside, that's going to give us negative sine x, and negative will neutralize this negative, so we'll have positive. And then we'll have sine x. It's very clear that we have sine x on each term. So it is logical to take sine x outside. So we'll take sine x outside. We'll be left with cosine square x minus 2 cosine to the power 4x plus cosine to the power 6x. One more time, we can see that we can reduce this between the curly bracket. We can reduce it further by taking cosine square x outside. If we take cosine square x outside, this is what we're going to get inside. So cosine square x now is outside along with sine x multiplied by sine x. So what we'll be left with inside between the curly brackets is 1 minus 2 cosine square x plus cosine to the power 4x. But the question is, can we rewrite this one in terms of multiplication of two values? Yes, we can. And this will simply be equal to 1 minus cosine square x multiplied by 1 minus cosine square x. If you want to check it out, you can just multiply by 1 minus cosine x by 1 minus cosine square x. You'll get this value. But now we know that 1 minus cosine square x is equal to sine square x. So we can replace this by sine square x, and we replace this by sine square x. And that's what we're going to get. So we're going to get sine x cosine square x multiplied by sine square x multiplied by sine square x. Now we can collect these two. This will give us sine to the power 4x. So the next line will show, instead of this curly bracket, we'll just eliminate it and put sine to the power 4x. Now we can switch sine to the power 4x and multiply it by sine x, and that will give us sine to the power 5x multiplied by cosine square x, which is what we want. We said the differentiation will annul the integration, and we will be left with sine to the power 5 of x cosine square x. And we did the differentiation of the integral, and the differentiation of the integral gave us the function back. And this proves what we want to prove. Thank you for watching this video, and you have a good day.